One thing is clear, AI is everywhere and AI will be everywhere, right? And we will use
hmm
AI on a day-to-day basis for all sorts of different things. And that is specifically relevant for personalized AI, right? Like having your personalized tutor that we talked about before in your pocket, having your personalized financial advisor in your pocket, having your personalized relationship advisor in your pocket, right? Those things will absolutely happen. And the question is, to get those things, who's going to own that data? And who controls the data?
Welcome to Open Podcast, your gateway to the digital world. So today we have Lukas, the ecosystem lead of Nillion, with us today. So Lukas, tell us about yourself. Give our audience a one-liner of who you are.
A one-liner is difficult, but no, I'm from Austria. I grew up in Vienna, and I'm super passionate about crypto. Started my journey in crypto basically doing my time at university, actually, which started 2017. So I did a couple of degrees in the UK, moving from Austria to the UK. Most recently, studying at Cambridge University, and during that period, we had the first sort of buzz around the application layer of crypto, right? So we had obviously Bitcoin, the first real mania around 2016, 17, but then 2019, 20, we had sort of the first applications happening on Ethereum with obviously DeFi Summer, being very prominent in 2020. And it was the time where I really started to dive deeper into on-chain applications. I was thinking about how we can build specifically financial applications on-chain that improve the traditional financial system. Always intrigued by, the principles of global access, composability, and ultimately the decentralization that comes with blockchains. As I said, specifically initially for financial services, but then in 2021, during my time at Cambridge, I met a bunch of guys at a conference that happens to be in crypto, or a lot of conferences. And we had a really good chat there about potentially building a new network, specifically focusing on privacy and technologies. So similar principles around like trustlessness, composability, decentralization, but for a different kind of data, right? Because on blockchains, we deal with data that is not sensitive, right? Data that we want to show the whole world. That's the whole point of
hmm
blockchains, right? Something we want transparently, visibly, immutably be available for anyone. But there's a huge amount of data out there that's sensitive, that's private, that you don't want to show to everybody, but still potentially benefit from these principles that make crypto, right? Which is sovereignty, which is, as I said, composability and trustlessness. I got very excited about this vision. That was the beginning of Nillion. So I'm part of the founding team. I've been working on it since 2021, which is three and a half years ago. And I've done different things ever since. And at the moment, my main focus, as you highlighted, is heading up the external side. So that includes sourcing, curating, supporting companies. So anything from BD to ecosystem to solutions to essentially get from 0 to 1, from sourcing one to actually get teams to market, which is fascinating because, as I said, this is not another blockchain per se, right? Where we kind of know the playbook of what the applications are, and
hmm
you kind of try to incentivize the same apps that already exist to come to you. The exciting thing about this one is really new design space, new applications that we have never seen before in crypto. And that's why I'm as excited today as I was 3 years ago. Seeing it come to life is thrilling. So, yeah, that's a brief background about myself. But generally speaking, I'm just super passionate about the space, and yeah, excited to keep building.
That's very cool. I think you covered a lot of my questions. So I was gonna ask you about.
Well, it's not a one-liner, but
Yeah, it's all good. That's all good. Love the
yeah.
detailed introduction. So, you're working in Web2 as a founder, right, doing school, and right after you founded Nillion, I guess. And through this journey, like, I'm like it's more of a straight line, I guess, for you. And I guess you're now in the crypto space, and you're still like pretty young, right? Because you go right off school and then right into crypto. And so, what advice would you give to people in their 20s to try to navigate through their career path?
And it's actually a really difficult question because I think today, the world looks very different than it did when I studied, frankly speaking. With AI evolving so fast as it does today, it's actually very hard to give the right advice because nobody really knows, frankly speaking, right, how quickly things will evolve from where we are today to, a more sophisticated level of intelligence, which
Mm-hmm.
obviously will impact any job and will impact any career path that
That's
people will
true.
take in. So it's really difficult to advise there. But on a high level, I would say that university is overrated. And I'm saying this as somebody who has taken 4 university degrees, and I've done a lot of them even simultaneously.
Okay.
I think that the degrees themselves don't really matter too much. What matters is the people you meet, the people that you take on your journey and that inspire you and that send you in a certain direction. Like the reason why I'm building in crypto today is mostly because I met people building in crypto during my time in Cambridge, and I got fascinated by it and read into it next to my own personal interest. But obviously, it certainly accelerated interest in this space.
Hmm.
Having the right people around you can happen anywhere, but it is true that I would say the probability of meeting the right people, very ambitious people, at some schools is still higher than in others,
Hmm.
or outside of school, right? I think a fact. But more broadly speaking, nowadays with everything being online, everybody can learn anything. And the sharpest people that I met either did not go to university or did not really care about what they studied because they did everything on their own time, and became some of the most successful or most inspirational people. So I think like you should follow. Again, this is like a cliche, but you should follow the path that excites you the most. Actually,
Mm.
build in a space that is growing. There's crypto; those are the 2 hottest fields right now. But beyond that, there are many other extremely exciting areas to build in. Try to be in those markets that are growing, not shrinking, obviously. But then at the same time, pick something that genuinely deeply interests you. Because I think if it doesn't, it's hard over the long term to keep motivation up, right? Because things are going up and down all the time. Things are very fast moving, particularly nowadays. And if you're not genuinely interested in what you're doing, then it's very hard to maintain that drive, right? So I'm generally extremely excited about like the core pillars of crypto. So for me, it's very easy to build in crypto because I
Hmm.
don't care if the price is at 78K of Bitcoin or 20K. I think the principles of it are very exciting. There's a lot of exciting things to build, and I think that's what everybody should try to find, right? That sort of industry and vertical that generally motivates them. So that's very high level stuff. But then, of course, on a more granular level, try to just build things, right? Like, I mean, it depends what motivates you. If you don't want to grind 24/7, that's perfectly fine. And there are a lot of career paths out there that don't need you to keep pushing every second, and you can still have a very, very, successful, amazing life. If you want to build new things, if you actually want to build products and want to found something, then I think it's important to just experiment and try out things and iterate and learn things that don't work and keep pushing, right? But the earlier you start building small prototypes or POCs, the better, because you will learn very quickly that uh, there is no linear path here in getting things done, and you will make a lot of mistakes, and I think from those mistakes you will learn, right? So I tried a few small things at university that to some extent did not work out. I did a tremendous amount of wrong things there, and I think I
Hmm.
learned how to do things and not do things on a much smaller scale. But the earlier you start with that, the faster you can learn from them, right? So that's kind of how I look at it.
Yo, I loved it. University is overrated. I do know a
Yeah.
couple founders that drop out from college and start their own business. I guess like Steve Jobs, they did the same thing. And so
I mean, it's
I,
not something that everybody can do, right? I wouldn't say to
yeah.
everybody just drop out. Like the reality is that sure, Steve Jobs might have done that, but in a lot of cases, university is still a very good foundation, not necessarily from a degree standpoint,
Hmm.
but just it gives you that entry into jobs to start with, and you learn the right people. You grade you develop your social skills. All these things are valuable. All I'm saying is that the actual degree in and by itself is probably overrated, and more, I think universities will have to dramatically change the way they're structured to continue
Mm.
to be relevant in society in next decades. But again, it depends a lot on how AI evolves, which is, depending on how fast we can actually get to AGI and the likes, right?
That is very true. I guess so. I'm like I don't think we're near AGI, but then AI is definitely going to transform our life a lot. We're gonna a lot of changes in the teenager's life. They don't really have to go to school. They just search online. AI can provide a better, more accurate answer, I would say, than their school teachers. Then what's the point of going to school? But
Yeah.
there's also
I
like
mean, I think
social
like
skills they can get.
actually,
Yeah, sorry.
yeah, I think actually in the short term, like, I see a huge opportunity to combine AI with traditional curriculums that we have today in schools, right? Like being able
Mm-hmm.
to have like your personalized tutor that is trained on a certain curriculum from a certain professor, fine-tuned on that basis, and is specific for you because it learns how you complete certain tasks, where your strengths are, where your weaknesses are, and knows how to teach it to you in a more personalized manner. That
Mm.
is hugely exciting, right? Like having essentially a tutor in your pocket 24/7 that you can talk to at any point in time. You can ask the stupid questions that you might not want to ask in the classroom.
Yeah.
Fine-tuned on, a bunch of professors that have a lot of experience in this. And that is super exciting, right? And I think that's maybe where, or probably where we'll go. Like universities will merge the traditional content with AI, and will be this sort of hybrid model. In the very long term, whether universities actually are still there or whether it just becomes social connection hubs remains to be seen. But I think in the short term, as you point out, I think that until we actually get to these higher levels of intelligence of AGI and beyond, they will probably be using AI in practice in school for just better teaching, right?
Hmm.
Which is a no-brainer to me that this can be done.
That does seems like a huge opportunity in education. Okay, let's get into knowing a little bit more about Nillion. So, but before we dive into Nillion, I mean, recently there are increasing speculation about Nillion. I'm seeing like different posts about Nillion, about the airdrop, and it's making some noise on the community and crypto Twitter. But let's set the stage. What's the story behind Nillion?
Yeah, so Nillion is a blind computation network. So, as the name implies, it's essentially a network of nodes who are blind. And blind means they don't see anything, right? They don't see what they store, nor do they see what they process. And it's essentially a, good breakdown of, describing privacy enhancing technologies, which are new technologies that exist for a while, but so far have not been very accessible and so far have not been commercially viable, right? Nillion's blind computation network enables essentially those technologies to work together. There are
Mm-hmm.
different technologies under this umbrella of privacy enhanced technologies. There's cryptography-based technologies like MPC
Mm-hmm.
or FEG, and then you have hardware-based solutions like trusted execution environments. But fundamentally, what the goal of those technologies are, they're focused on bringing back control to users in data ownership. So instead of you having to entrust a third party with all of your sensitive data, which in the past has proven to be not a good idea
Mm-hmm.
because many times they've shared it, exploited it, misused it. You're the true self-sovereign owner of your data. So that's a key principle of it. And then most importantly, beyond that as well, you can keep your data private and secure throughout the entire life cycle. So not just do you own your data truly, but even if you use your data, even if you process your data, the data is always fully encrypted, right? Which
Mm-hmm.
is new because today when you process information, the data is actually not encrypted, right? It's actually exposed. And that, comes with the risks that come with it, right? Which is, you're exposed to hacking attacks, but at the same time, again, you have to entrust that party that has access to the information that could arguably retrieve it and use it.
Yeah.
So these privacy technologies really are the next generation of in keeping your data truly end-to-end encrypted. When we say end-to-end encrypted today, it actually does not give justice to true end-to-end encryption because when you keep your data stored, it can be encrypted. When you transfer it, it can be encrypted. But doing processing, it cannot be encrypted today. And
Mm-hmm.
these privacy technologies can do that. And that is the exciting sort of new vision. And Nillion is building a network that taps into these technologies. So you, as an ordinary developer, can build applications with those technologies, even if you have no experience in with them, really, right? That's the vision. So today, the first entry in using these technologies, they're very high, specifically on the cryptography side, right? Unless you have like PhDs in multi-party computation, and yeah, you have basically no access to this. And
Mm-hmm.
even then, it's hard to build with these things, right? It's not accessible. So the first big vision is democratizing access to that, and the second part of that is, as I said, to reduce the friction to combine these different privacy and technologies, and as a consequence, also make them commercially viable and really implement applications that tap into these technologies. So that's the big vision of Nillion, which is really a foundational pivot, right? A paradigm shift in how we think about data ownership, how we think about data processing, and how we think about data security.
Okay. Um, in terms of like decentralizing data, I guess a lot of people like don't care about it. For now, we know we have a lot of regulated systems like frameworks from like Google, from Apple, from Microsoft, these big tech giants. Essentially, they own their tons of user data. And but these user data is we are talking about decentralizing them. They like go beyond these big tech controlled infrastructures because most of us now these data are controlled by them, but it's also like well regulated. It has a like law framework and it had very well stored. So why do you think that normal general public needs to, move beyond these, frameworks or big tech companies to go decentralized?
Yeah, so I think there's a couple of points. So the first point is the security angle, right? So if you use these privacy and technologies, specifically cryptography-based like MPC, where you distribute trust across end parties, then you have high levels of security. So even if you hack one of the nodes, then you have arguably no information probabilistically. So you would have to have sufficient number of shares to actually reconstruct the underlying information. So that first argumentative is the security argument, right? That it's ITS secure using MPC, information threat secure. That means which is the highest level of cryptographic security, and is thus robust even in an age of like significant attacks. That on the consumer side, I would agree with you, is probably the weakest, although it's a very important one. But consumers today are not thinking too much about that side
Hmm.
of things. But it is a very important point, specifically for enterprises that are absolutely thinking about this. The second key point of it, I think, is that it can actually not just provide high levels of security and privacy, but it can actually unlock new opportunities and use cases that otherwise would not work, right? I'll give you examples. So let's pretend we think about healthcare and I have some of my variable data on Aura's server, and then I have my Google Calendar with Google, and then I have maybe my Apple device, my fitness device, stored my data on a different server. I cannot currently collaboratively analyze this information because the data sits in different silos, right? The data is
Hmm.
not composable. And that is a huge issue because we are missing out on insights, a tremendous amount of insights that is currently just not available because the data is not sitting in the same place and is not able to be aggregated properly. And most importantly, not aggregated collaboratively across users, right? And that comes with privacy, security, and sovereignty considerations. So Nillion breaks down those barriers because as a blind computation network, it's a credible neutral data layer. So you can store your data there. You're a sovereign owner of it. And then you can give third parties permission to use the data without seeing the data to analyze it, for instance, right? And that is useful for you as a user because all of a sudden you identify new insights that otherwise you wouldn't be able to identify. Like, for instance, how does noise exposure impact my sleep? That's just one random example for
Hmm.
somebody who is very fitness conscious, right? But those insights exist across all spectrums because, like, any data point that you combine with others is giving you new insights. But most importantly, also, it can unlock new income opportunities and monetization streams because there are third-party companies that are very interested in acquiring insights like this, right?
Hmm.
And so that's the vision of these data marketplaces that are currently being built out in crypto, ranging from DePIN to DeSci, and we see a bunch of builders in our network that are building in this sort of intersection. You can think of like insurance companies being interested in acquiring insights how people drive cars, right? At what speeds, when do they drive, and all that sort of stuff. That's information that you can now compose and aggregate across users in fully encrypted and privacy-preserving environment, and nonetheless enable people to benefit from sharing that data, right? Because companies pay for it and they can then distribute the rewards to
Hmm.
users and really establish a proper attribution mechanism as a consequence. So again, first point, security. Second point, I think, is the unlock of new opportunities, use cases, and also income opportunities.
Hmm.
And then third, I think we are approaching an age of an intelligence explosion. I mean, we were talking about this for the call a little bit before. We're not sure exactly where we sit on
Yeah.
the timeline of AGI explosion. There are different opinions out there of a lot of very reputable people that have different thoughts and ideas there. But one thing is clear, AI is everywhere and AI will be everywhere, right? And we will use
Hmm.
AI on a day-to-day basis for all sorts of different things. And that is specifically relevant for personalized AI, right? Like having your personalized tutor that we talked about before in your pocket, having your personalized financial advisor in your pocket, having your personalized relationship advisor in your pocket, right? Those things will absolutely happen. And the question is, to get those things, who's going to own that data? And who controls that data, right? And I think it's pretty scary to think about a future where every single detail about you that makes you you, every single message, every single URL data point that you collected over your years, every single Amazon purchase, every single song that you listen to on Spotify, every single data point that makes you you is controlled by one company. I think that's a
Hmm.
pretty dystopian future to think about, right?
Hmm.
So again, to prevent that from happening, we need a new paradigm of computing and data ownership. And this is what privacy enhancing technologies aim to enable by bringing control back to use the user and nonetheless use the data effectively in practice by, for instance, enabling agentic applications to tap into this rich data source, utilizing this credible neutral data layer that Nillion is building, right? So a pause there, but I think that on multiple fronts, there's the very strong macro drivers, and then beyond all of this, there's actually, I think, also a regulatory component that we can talk
Mm-hmm.
about that I think could be a bullish catalyst for pets,
Okay.
because you look at GDPR and others, like the governments are very interested in protecting data security of course, right?
Yeah.
And today, the way this works is that you have to anonymize the data, and it's a pretty burdensome process for companies to de-identify certain personal identifiable information. If you can use privacy-enhanced technologies that keep data encrypted end to end, that is a significant improvement for
Mm-hmm.
consumer data security and protection that at some point might even be legislated, right? To be compulsory to use. We're not there yet, obviously, and these technologies need to mature but that's obviously the term potential impact from a political side and from a regulatory side that I think could also drive significant adoption, because as I said, the principles of sovereignty and data security and data privacy are very much in line
Mm-hmm.
with a lot of the frameworks out there.
So when you talk about like this blind computation being implemented into the real world, where were we? Like, what like 0 to 100? What do you think we are?
That's very difficult. Depends on what 100 means. If 100 means everything is using, everybody is everywhere is
Yeah,
using
like you
blind.
can easily use blind computation to, secure your
Yeah, but
data and then do computation to others. And like the magnitude of the data is like massive, gigabytes up to
yeah.
another scale, etc.
So to answer this question, I would say that on the cryptography side, using multi-party computation for storage specifically, like Nillion, for instance, has called NilDB, which is essentially an MPC-based secret shared storage
Mm.
product. It's pretty at this point, right? It can store a lot of information and enable sovereignty for users, and can scale horizontally and vertically. So
Okay.
it can actually store a substantial amount of information, and no real, you know, compute restrictions that on the storage side that we otherwise would have to deal with on the computation side, right? On the computation side, MPC and FHE are still, in the process of actually being able to run these computations at scale, particularly when it comes to like larger computations. Like
Mm-hmm.
if you're trying to run language models in FHE or MPC, it's going to be slow, right? It's not there yet in production for consumer use cases, because in these use cases, users are expecting very fast responses.
Yeah.
And these cryptography-based technologies cannot do that just yet for these larger models, right? So a more nuanced answer to your question would be on the storage side, cryptography-based technologies and they can scale from a storage standpoint using secret sharing, using MPC as NLDB does. But then as well, at the hardware side, actually, we now have solutions like trusted execution environments that
Mm-hmm.
can scale, I would say, in terms of like run computations that are particularly complex and heavy. Like large language models, Llama 70B and the likes have almost no performance overhead compared to plain text performance, right? So where it's really getting exciting is combining those two, of using cryptography-based technologies for things like storage and querying and aggregations, and then using hardware-based solutions for the heavier computations. And under these circumstances, under this sort of constellation architecture, privacy technologies are significantly becoming more viable as of today than they were just a few years ago. But again, the would be more nuanced in terms of what privacy enhanced technologies you mean under blind computation, because again, it has
Mm-hmm.
difference, right? As MPC as well as FHE and Ts, and they all have their sort of performance trajectory and trajectory. But combining them, as I just explained, essentially enables blind computation to work, and that's very exciting to see in practice.
Okay, in terms of like applying into real world, like, are you guys like currently working with any Web2 companies already implementing this blind computation in their like whole system?
Yeah, I mean, there's a wide range of use cases that people are building on top of Nillion today. Like some of the ones that I'm most excited about is the stuff in AI.
Mm-hmm.
As I said, on the AI side, obviously, it's all about personalized implementations. It's about utility agents, right? That know you better than you. So you need to find a storage layer for all of your personal information. Again, NilDB, as I described before, which is this sort of MPC-based storage layer. can be this credible neutral data layer that enables you to store information, provide granular permissions for other people to use that information. Then we see Nillion being used for RAG and also the ultimate inference of the model. So the end-to-end flow of agentic applications for things like, to be specific now, personalized Telegram assistants or personalized digital assistants more broadly, personalized relationship advisors. All these sorts of things needs this end-to-end flow, and people are building these applications as we speak, right? So think of your Telegram assistant as an agent that scrolls for all the Telegram messages and highlights the messages that need to be responded to, and is able to draft messages for you, knowing how you write, knowing who you are, and then all you need to do is accept or reject the message, right? I think everybody in crypto will see this is great, this is awesome, right? Because everybody is kind of a little bit struggling to some extent, at least when it comes to Telegram. Privacy is critical here because the messages are pretty sensitive, and likewise, people even make deals on Telegram, right? They share contracts. So all of this data needs to be kept secure and private, and we see applications like this being developed as we speak on the network. Where I'm also very excited about is our healthcare implementations. So DeSci, as of today, is mostly a funding vehicle, right? People are trying to fund research and provide attribution back to contributors in sort of research. What I'm very excited about is this next wave of DeSci, where you have actual real-world applications that need to store and process very sensitive information and enable composability. So think of use cases where I might build or I might store my genetic information in there. There's a company called Magnetic DNA today on Nillion that is building exactly this, where we're storing DNA data in Nillion, and then you can give granular permission for other people to run analytics on your data without revealing it, right? In an age of 23andMe, having been hacked and going out of business, there needs to be an alternative, a truly decentralized, sovereign, trustless alternative that brings back control of your DNA data, and most importantly, above everything else, enables you then to compose, right? So imagine you being able to combine your DNA data with your Spotify lists or your verbal information, whatever it is. It can be any arbitrary data point. All of a sudden, we will learn new insights about us as human beings that we just have no idea about as of today, because the data sits in different places. You cannot actually bring them together and analyze them. Not just for you as a user individually, but actually collectively as a social group, right? This is creating new collective social intelligence. I think is very, very right. And you need a credible, neutral, sovereign data layer for this that is focused on privacy and security. And that's what Nillion and blind computation is building. So these things are being built out. Happy to dive into more detail there. But that's real stuff. It's happening as we speak. It's a process. So that's not just theory anymore. And a brilliant example of like blind computation not just being theory anymore, but blind computation actually starting to become commercially viable and being used in production.
Wow, that's a very cool use case. I'm also excited about like able to share like personal data and then analyze on top of that. Like that's also giving this blind computation is also giving a lot of sensitive data company that owns that data a new opportunity to get like their income resource in terms of they're able to sell their users' data and without revealing their data. And of course, sharing the revenue to the users as well. That's awesome. And
yeah, and if you think about it, it also is economically pretty strong, this argument, because like the difference between the way the things are dealt with today and this one is the way things are dealt with today is you sell your data if you want to. Even a lot of people don't even sell the data. They don't even monetize it at all, right? But that the companies often have sold their data and then they benefit from it, right? But even if the user actually sells the data, even in this scenario where the user actually monetizes their information, they sell the data, and once they sold the data is out of the bag. The cat is off the bag, so to say, right? Because now that other company has all of the information they need to do whatever they want to do with it. Which means at this point in time, you had one financial transaction, you monetized your information, but after you monetized your information, it lost its financial value, right? It's a one-off. The beauty about blind computation is you can keep your data private, make it accessible and usable by third parties, but consistently generate new income because your data always maintains its economic value. You're turning a dead asset into a productive asset, right? And that's the exciting income opportunity and the sort of economic potential of these blind computation networks, because there is a real economic reason to keep your data private, even if you don't care personally about security, privacy. You might care about monetization. You might care about income opportunities, and they are almost certainly going to be higher if your income maintains its value or the asset maintains its value over a long period of time.
That's very true. That's when you mentioned about like blind, I mean the MPC storage, when as a user or as like normal general public, if I store my data into like so for example the MPC database, is it going to be encrypted first and then stored in, or like are you guys gonna able to see the data? Is it gonna
No,
be
so
encrypted in the data?
yeah, so you could use NILDB even for unencrypted data, but you absolutely can encrypt it and secret share it, which means that the way it works is there are different clusters. So the Nillion network and specifically NILDB as a module is cluster based. Okay, so there's a cluster of nodes that you can configure. So you can determine who the nodes are, where they're based, what sort of security assumptions they have in place. Like,
Mm-hmm.
are they running cloud instances? Are they using TEs as defense in depth? So you can pick and choose. And when I say you, I also mean the application itself, right? So you could be a user using the application. You have no idea about any of this stuff, and you don't need to know about any of this stuff. But they provide the guarantees by building an app on top of the network as an application that exposes the benefits to use the user without you having to directly interact with any of this stuff, right?
Mm-hmm.
So that's essentially what that means is abstracting away the complexities. The same way as crypto needs to find a way to abstract away all the complexities to deal with crypto, blind computation needs to find a way to abstract away the complexities to interact with privacy enhanced technologies, right? Because if you as a user have to learn all these things, you can forget it, right? Like we need to get to a point where the friction for developers to use these tools is down to zero, such that the obviously integrate this into the app, and then the user gets the benefits from it, but doesn't have to deal with all of these different nuances and details about how the tech works, right? But in a nutshell, to answer your question, yes, you can encrypt the data obviously locally, so you can secret share information locally, send the data then as a user to this cluster of nodes. Every single node has one share of it, which means none of the nodes have any viable information
Mm.
unless the nodes collude,
Yeah.
right? There's a security threshold assumption that you have to have in place. And unless they collude to, you know, with that threshold, then your data is essentially secure and you don't need to encrypt the data. So you could have some information that is just not sensitive that you store in there anyway, but absolutely can enable secret sharing and NPC-based distribution of trust.
Mm. Wow, okay. That's a lot of information. As in very bullish information. I think of so many use case right now, just leveraging on top of blind computation. Very bullish on the whole idea and how it can be implemented into the real world. What do you think, like as in like this blind computation and Nillion move on onwards, what do you think is gonna be like the biggest roadblock of this technology?
So on the cryptography side, there's still time needed to actually make commercially this cryptography-based technologies commercially viable from the perspective
Mm-hmm.
of computation. And when I say computation, there's some computations that are already viable, but running bigger models, for instance, like language models, as I said, in
Yeah.
MPC or FHE is there yet, right? So I would say there's more time needed to get there. The good news is I think there are many first that are bullish when it comes to driving acceleration for this, right? So some of them actually have nothing to do with cryptography. What I mean by that is latency issues are getting better,
Uh,
right? Like bandwidth is improving all the time, hardware is improving all the time. Then you have algorithmic efficiencies consistently happening, particularly in the AI space right now, right? Models are getting smaller and smaller. At least, I mean, models are getting bigger and bigger at the same time, but like very good models are getting smaller and smaller, right?
yeah.
And there are techniques like quantization and others that enable you to run these models pretty effectively locally, even sometimes. And it's a trend that we have seen over the last year and two that some people did not believe would be possible, right?
Mm-hmm.
But all these things are bullish for privacy and technologies because the smaller the models, the less parameters there are, the less layers there are, the better, right? Because there's less computation needed to run these computations, to run these models. So we do have these benefits. Then there's also new research, specifically in the cryptography side, that makes things faster. So, for instance, Nillion worked with a meta researcher on improving activation functions for large language models, substantially improving the theoretical performance previously that has been published, essentially accelerating the speed with which you can run inference on AI models, right?
Mm-hmm.
So all these things combined, the macro level stuff like hardware bandwidth improvements, algorithmic efficiencies on the AI side, as well as actually cryptography improvements, will improve the speed with which cryptography-based present technologies can evolve.
Mm-hmm.
Next to that, however, as I said, already in the short term, there are hardware-based solutions like trusted execution environments, which give you much better privacy protections and verifiability at the stations that you otherwise wouldn't get, that are already commercially viable, frankly speaking, from a performance standpoint, right? So depends what you mean with world blockers, really. Blind computation is, as I said, this that combines these different technologies, some of which are already far ahead, but with reverse trust assumptions.
Mm-hmm.
The others with better trust assumptions and better security assumptions still need more time. But collectively, it's very, very interesting to see that already in the short term, you can use it. And in the medium to long term, you can use it with even better security and trust assumptions, right? That's how I see it.
Yeah, I very much agree. I think for now, because just talk about decentralized AI, it will take a lot of time and effort for the technology to be in place in terms of the bandwidth of like the communication overhead, and for like the speed of like the internet, like everything, because you need a decentralized network. The nodes need to communicate with each other, which is gonna take a long time. For example, if you wanna like train a model, if you wanna do any communication stuff. So I think it might be the infrastructure might be the blocker, but in like it's gonna grow and it's gonna be more advanced. But I love very much love the idea of blind computation and how it can be implemented into the real world. If we fast forward to like say 5 to 10 years, how do you see this pet technology or say Nillion gonna shape the digital world?
I mean, yeah, if competition evolves the way we hope it will, then blind competition will be omnipresent and ubiquitous across many digital interactions that people are having on a day-to-day basis, right? Meaning that applications do adopt blind competition, do adopt hardware and cryptography-based solutions as the standard for building applications, both from a storage perspective as well as from a computing perspective. The same way as you can think about HTTP morphing into HTTPS,
Mm-hmm.
right? You can think about storage and computation moving into blind computation in the future, right? It's a standard that people will adopt. People don't know, even really truly need to know, right? As a user, it's abstracted away
Yeah,
from you,
I love
but
the
you get the
analogy
benefit.
of
Yeah,
HTTPS.
it's the benefits of it as an end user, right? From a security, from a privacy, from an income standpoint. But you don't truly understand how these things work, and you should not have to, right? Because
Yeah,
if you have to understand all these things, then it's not going to work, right? Like
yeah.
the job is for things to be built, to be viable, to be commercially viable, but then also to be easily usable and adaptable by
Mm-hmm.
these applications that build on top of. So that's the end game, right? Of it being just ubiquitously available. I think to get there, we're going to see obviously a step-by-step process, right? So already today,
Mm-hmm.
these applications are real, right? Like it's extremely exciting, in my personal opinion.
Yeah.
My personal opinion, the most exciting thing right now in crypto to see things like DNA applications being built on this network. Like for me, this is way more exciting than having another DEX that's 0.001% faster than the other one. I don't care,
Yeah.
right? Like we have DEX, we have enough of them at this point. We need to get something new, I think, into the
Mm-hmm.
space that actually expands the design space of what decentralized infrastructure can do. And having people that actually collect samples and store the DNA data in there and doing aggregate analytics on that is fascinating. I mean, it's
Mm-hmm.
historical, right? We've never seen this actually happening before, and it's happening right today, right? A Nillion. So these things, I think, will happen. Like more and more applications will the usage of it. As I said, there is deep in applications, there's yes applications. All these teams are
Mm-hmm.
already building, and then we will get to a point where bigger enterprises will also start to explore and with these technologies, right? So they will actually start integrating parts of the stack, not all of it overnight, right? It will take time because a lot of the more traditional companies in the Web2 space, they're risk averse. They have a lot of reputation to lose. They don't just move overnight. It takes more time. But like, especially, I think it will become, ultimately the state, right, of how we store and compute information, irrespective actually of whether there is like a regulatory driver or not. Of course, a regulatory driver will massively accelerate it. But even without that, companies need to think about security. They need to think about privacy. That is the essence of their business,
Mm-hmm.
particularly large enterprises. And if technologies exist out there that can help them in doing that better and more efficiently, obviously, they will very much consider using them. So Yeah, I think the end game I described, and I think to get there will be a step-by-step process. Nothing happens overnight. I think
Yeah.
anyone saying that would lie. But it's very exciting to see already today what's possible, right? And it's not fear anymore. It is happening, right? And it is happening already across many applications.
Yeah, dude. Such a good speech. I'm already worked up by just listening to you talking about the future prospect of blind computation. Can you give us like a brief, if like the roadmap that you guys are currently working on? Like, what's the status of Nillion now? You got do you have a mainnet and moving on? What's
Yeah. So we are still in testnet, but
okay?
literally this month we're heading towards we announced
Mm-hmm.
that, which is super, super exciting.
Awesome.
So at this point, a lot of the applications that we have right now in testnet will move into production, and other builders that are currently building out their applications are going to move straight into production soon. So as I said, this ranged from healthcare DeSci to DPIN and stuff. We obviously will keep expanding that
Mm-hmm.
ecosystem and specifically build out the actual real world use cases across these verticals. And from a technical perspective, we're going to expand the modules and also enable those modules to interact with each other.
Okay.
So I mentioned before, there is NILDB, which is sort of this MPC-based storage layer.
Mm-hmm.
Then there is also the ability to run computation in TEs, enabling that interaction to work efficiently and at scale is obviously a key priority. Next to expanding on the cryptographic primitives that are made available in the network, right? So I mentioned before, Nillion is all about orchestrating between different proprietary technologies. It's not the one or the other. It's not just MPC. It's not just FAG. It's not just
Mm-hmm.
TEs. The power comes in when you bring them together. So building out more of these primitives, integrating more of that into the network, and connecting them is a never-ending development journey, which is exciting because every week somebody comes up with like slight improvements somewhere on the cryptography side to make things faster, and actually implementing these things in the network and also connecting them to the other modules will obviously be a key focus for us going forward on the technology side of things, right?
Mm-hmm.
So those are really the things for us. Building the tech side and at the same time scaling the number of real world applications that wouldn't be possible without Black computation to really exemplify what it can do to unlock new design space.
How is the ecosystem right now? Like
So
how
we
many
do have
projects on?
So we do have over 50 teams that have signed up to build on Nillion, and as
Okay.
of today, we have many of them actually moving into production or have already moved into production internally, but are moving into public production as we go into mainnet,
Okay.
across a wide range of use cases. So some of it is infrastructure integrations.
Mm-hmm.
So think of other AI networks that are interacting with Nillion or blockchains that are actually enabling apps on chain to just request to Nillion, as well as actual native applications on top of it, like variable companies, DNA companies, AI agents, as well as just like profit preserving general purpose LLM interactions. All these things are building up right now, right? And
Yeah.
moving into production. So it's very exciting to see that rough use cases.
Yeah, that's some very exciting news. So you guys are in testnet right now, and you guys are gonna go mainnet very soon,
Yeah.
and there's gonna around be like 50-ish projects already building on top of Nillion.
Yes, so not all of them will be live,
Okay.
but some of them are in the process of building. Others are going to be live pretty much with mainnet release, and many of them are following instantly afterwards. But not all of them that I mentioned there are already production ready. Some of
Yeah,
them are building or starting to build, but there will be a good chunk of teams that will be live literally with mainnet release and after. Yes.
that's awesome. Okay.
Yeah.
Last but not least, how can we find you?
How can you find me online? I think you mean.
Yeah,
So
like
how can you
how can our listeners like find you or about more info about your project?
Yeah, so I mean, obviously the big phase of Nillion is Twitter,
Hmm.
or X we call it these days. I still haven't made that switch yet to X, but
Same.
on Twitter. So that's where most of the public information is shared, and then Discord is where the community is at home. We have a great team there that is 24/7 available to chat with everybody in there. There's a home for everybody, and yeah, I would say those are the two key ones.
Hmm.
And of course, from a development standpoint, if you guys are interested in building, we have documentation available on our
Ooh.
website that guide people through how to build stuff. And there's also a support package in place, like a Nucleus program that we have put in place, which is a program to support builders in the early stages to build applications on our network.
Hmm.
And we do provide a comprehensive range of support
Oh,
from
nice.
go-to-market, technical, financial, to bring teams to market. So there's something for everybody, and yeah, we'd love to see people out in the community supporting us or actually building implementations, demos, actual apps on top of the network. All of it is exciting.
Awesome, awesome. Just find them. Find Nillion on Twitter. You can find Lukas on Twitter too. I will put the Twitter on the show note. Also, you can find them on Discord. They also provide grant for the network, and this grant is like for financial, for development, all kind of resources they can provide. So check it out. Nillion's also launching their mainnet soon. There's a lot of new things coming on. They're working with real world use cases and Web2 companies. Yeah, very excited. And thank you today for coming, Lukas.
Thanks, guys, for having me. It was awesome.
Yeah, have a good day, man.
Cheers.
Cheers.
Ciao.